Assalamu alaikum students. I hope you all are doing good. Students, in our previous class, we have started chapter number 11 of your science books, that is effects of heat energy. We've introduced the topic of thermal expansion and contraction. So now we'll move to the next topic of this chapter. Our objectives for today's lecture are review of the previous topics, effects of expansion and contraction in everyday life, applications of expansion and contraction, and in the end, the conclusion. So before moving to the next topic, let's discuss promptly the previous topic. Thermal expansion is the tendency of a matter to change its shape, area, and volume in response to a change in temperature, whereas thermal contraction is the shrinking of substances as they cool. Changes in temperature changes the physical properties of the substance. And then the thermal expansion in solids, liquids, and gases. The particles in solids, the particles are not free to move. Solids do not expand much. For example, leaving the spaces in between the rail tracks due to the expansion process. And in liquids, the particles move more freely than in solids. Liquids usually expand more than solids. For example, here we have taken the example of a mercury. Mercury expands when heated. And then thermal expansion in gases. The particles are far apart and move more freely than in liquids. Gases usually expand more than liquids. As in this, the gas inside a balloon expands when heated. So this was our previous topic. Now discuss the effects of expansion and contraction in everyday life. We'll be discussing some useful effects of this thermal expansion and contraction and some nuisance effects of thermal expansion and contraction and how we can overcome on these harmful effects. So, some useful effects are, as you can see in the first example, this metal frame of a wooden tire can be fixed on this curved wooden tire by using heat, or the tight lid of a jam bottle can be opened by placing it under a hot water, or blowing this huge balloon can be done by the effect of thermal expansion. Likewise, the expansion and contraction of mercury when it is placed in a hot or a cold water, respectively, which helps to measure the body temperature. Or two metal plates can be fixed or tied with one another tightly by the riveting process, or this kettle can make you a hot coffee or a tea by the effect of thermal expansion or contraction. So we are encountered with the thermal expansion and contraction effects in our daily life. We have discussed the useful effects of thermal expansion and contraction, and now let's discuss some harmful effects of thermal expansion and contraction. Look at this first picture. Have you noticed these cracks on the road outside your house? Why is it so? This happens because of thermal expansion. Due to heat, the road gets warm and expands. as there were no space left in between the road to allow expansion. The road gets crack on it. You can see small rocks on the road, or due to the cold, the the road particles gets contracted, and again the cracks appear on the road. This is the bad effect of thermal expansion and contraction. See the next picture? The railway tracks are detracked, and if the train moves on these tracks, what do you say? Will the train continue to move in straight path? No. This can cause accidents to happen. But why this happens? Who did this? This is because of the effect of thermal expansion. The particles expand on hot summer months. Look at the third picture. What is the pendulum clock doing here in this topic? Does it have any relation with this topic, that is effects of thermal expansion and contraction? Yes, it has. Let's discuss. In hot summer months, the pendulum of this clock gets heated and expands, and vice versa. That is, in cold winter months, the pendulum gets contracted. As we know that this pendulum determines the time, that is, help in seconds calculation. So, due to the thermal expansion or contraction, the pendulum shows abnormal oscillatory motion, and hence causes hurdles for you to measure accurate time. This is also a bad effect of thermal expansion and contraction. Now see this next example of bridge. Oh, it is broken. Why this happens? This is also because of the bad effect of thermal expansion and contraction. Can you think why? Think for 2 minutes. Got the point? Yes. You can blame the effect of thermal expansion. The metal gets heated and expands and make the bridge in this condition. So what are the remedial measures of this nuisance effect of thermal expansion and contraction? Let's see. In order to prevent the cracking or buckling of the roads, engineers now are using this metal sheet, leaving a space for the particles to expand or contract. This is mostly done on such pathways that contains heavy traffic. Or you can see the space is left in between the pathways, as it is shown in this diagram. Second is, to prevent the railway tracks comes in this condition, the engineers leave spaces in between the track after some uniform intervals, and due to this, the track can easily expand or contract. And this is the reason why we hear a different type of voice when the train is moving. In order to prevent the damage of this bridge, a rolling or sliding wheels, as you can see in this picture, are placed under the bridges, which helps the bridge in times of expansion and contraction. Another example, if the buckles or these bends are not made in these liquid or gas carrying pipelines, due to expansion and contraction, the pipes may damage in this way, as these pipes are the carriers for the hot or the cold liquid or gases. This is another harmful effect of thermal expansion and contraction. If these overhead power and telephone lines are held too tightly or too loose with these poles, due to expansion and contraction, these power lines can either comes near the surface, Earth's surface, due to the expansion, or contracts tightly due to cold. So these power lines must be fixed in such a way that they are neither so loose nor so tight. So, in order to have accurate time, engineers use bimetallic strip in this clock. They are placed in the clock in an opposite direction or in such a way that if one metal expands downwards, the other will expand slightly lower or upwards, and hence both the effects will cancel the effect of each other, and you can have accurate time. These Pyrex glassware do not usually crack when hot liquid are poured into them because they expand very little when heated. That is the reason why most of the laboratory equipments are made of this material, Pyrex material. So these were some useful and some harmful or noxious effects of thermal expansion and contraction. Now let's move towards our next topic, that is application of thermal expansion and contraction. One of the application of expansion and contraction is used in this hot air balloons. Hot air balloons depend on the low density of the air to float. Heat is applied to expand the air in the balloon. With the air expanded, its volume will increase, causing its density to decrease. This results in the hot air in the balloon to rise, thereby floating the hot air balloon into the air. Another application of thermal expansion and contraction is in most of the electric appliances. Bimetallic strips are used as adjustable automatic switches. As you can see in this picture, that when you supply electric heat, the kettle starts working because both the strips are in contact with each other at room temperature. But as soon as the kettle absorbs more heat, and reaches to the strips, after reaching certain level, the strips get heated and will bend in opposite direction, and hence the contact gets broken. Same is the phenomena going on in your automatic geysers or fridges, etc. Another application of thermal expansion and contraction is particularly the role of bimetallic strip in these two instances. This iron press also works on the same principle. This is the screw or the knob of iron press. The screw adjusts the temperature at which the contacts open and the appliance switch off, whereas the brass strips on top expands more than the iron strip when heated, causing the bimetallic strip to bend and break contact. And this one is the heating element. So when the iron gets too hot, the strip bends and break the connection. This is a bimetallic thermometer. A bimetallic strip can be made into a long, nearly flat coil, as you can see in this diagram. If it has one end fixed and the other carries a pointer, the coil tightens or unwinds as the temperature goes up and down. The pointer then moves over a scale marked in temperature degrees. So this is how the bimetallic thermometer works on the principle of thermal expansion or contraction. Another application of thermal expansion and contraction is this metal frame will expand upon heating and then fix to this wooden wheel of bull cart that have slightly higher diameter than this metallic frame. Due to the expansion, this wooden wheel get fixed into the frame, the metallic frame. Let's see a practical application of this phenomena.
Go on about 10. So we've got 85 and 7/8, 86 inches. 86 times 10 is 860, which is 7/8 of an inch. And we only need 3/8. So the circumference should be half an inch more than we need. If the tire is as hot as that bar, I've got that bar right in the coals. Chances are it's not as, the tire's not as hot. The thing is these little clips you see are sticking down.
Right. So you're going to remove them once you put the wheel on?
The tire will go right down to here.
Okay.
The tire is the same width as this.
Right.
So the tire will cover the whole wheel. If you didn't have a piece of metal in there, it wouldn't cover the whole wheel maybe.
Okay, it'd stick out on the top.
Right. Okay.
Okay, yeah.
Well, just watch this crack right here, how it comes up. Right here.
As you can see that now they are pouring cold water so that the frame gets contracted and gets fixed into this wooden wheel.
I don't have many ships to put along with it.
So it's just
I don't think you're handy at
wood
this, Boone. I
from
think you've
burning
been doing
Yeah.
it before.
Didn't you, Lindsay?
Yeah, we did 5 in Lindsay.
Yeah.
And you did 1 or 2 up in the shop.
Still warm? Yeah.
Oh yeah. Oh yeah.
You can really see the gas burning.
Oh yeah, you can, hey?
It'll come in.
Now let's talk about another application of thermal expansion and contraction. If you want to join two metals together tightly, you can use the process of riveting. Rivets are used to join steel plates and girders. First process, when red hot, the rivet is put into position. In second step, it is hammered into a head and then allowed to cool. As the rivet cools, it contracts and pulls the steel plates together. Let's see a practical example of this process. are putting a red hot rivet to join two metals. They are pressing this rivet by the help of a machine. One can also use a hammer. Another application of thermal expansion and contraction is used in the thermometers. When we place a thermometer in a hot beaker, the molecules gains heat and will expand the mercury. This causes the mercury in the thermometer to rise. Whereas, if you put the same thermometer in a cold water, then you will notice after a few seconds that the molecules of this mercury will be cooled and contracts in this bulb. And this causes the mercury in the thermometer to rest in the bulb or to move in downward direction or backward direction. Now let's discuss the application of thermal expansion and contraction in fire alarms and indicator of car. This is the circuit of a fire alarm. As soon as it catches the heat, the bimetallic strip bends, and hence, by completing the circuit and reaches to the sensor, the bell starts ringing, and everyone gets alert that there is a problem, for example, in a building. In this instance, a source is provided and this bulb of the indicator will glow. But this process happens so rapidly that in a second you can see several times the glowing of this bulb. So these are all some of the applications of thermal expansion and contraction. I hope up till now you are clear with the topics. Let's summarize what we have studied today. Effects of expansion and contraction in everyday life, and applications of expansion and contraction. You can think of some more examples in order to make your concept much more clear. Now you people are pretty much able to do your worksheets. I am waiting for your 99% response. So, till the next video or the next topic, take care and Allah Hafiz.